Assalamualaikum dan selamat sejahtera. My name is Mohd bin Yusuf. I'm a semester 7 from UiTM Shah Alam. So today I would like to present about my final year project 1, which is study on design and analysis of car chassis for NF2 car. So basically we are designing a two-seated car in this project. So my supervisor is Sir Muhammad Hamid Mat and my co-supervisor is Sir Zaki bin Hassan. So the content here, first I will explain about the project summary, and second, the introduction, which includes the objectives, problem statement, and also literature review. Next, the methodology of this project and my expected result. So my project summary is to design a thesis that needs to consider the front impact, rear impact, and side impact, and for the torsional stiffness. To achieve the maximum performance and obtain low stress occur on the chassis in static condition and dynamic condition. So as you know, chassis is like a backbone to a vehicle. So what does the function of the chassis? So chassis is basically support the load of the vehicle body and provide space and mounting location for various aggregates of vehicle and support various systems such as engine, transmission, passengers, drivers, and many more. And lastly, to withstand stress during braking and acceleration of the vehicle. And besides that, chassis also protects the driver during an accident or any impacts that occur on the body. So this is the type of chassis. First is the tubular chassis, which is commonly used for racing car, and second is the monocoque chassis. Uh, this is we usually see on the road. Most of the friends are using this chassis, such as Patar, uh, many more, Toyota. They also has the advantage and disadvantage for uh, chassis. So this is the advantage and disadvantage for tubular. So tubular has the better rigidity compared to chassis in the same weight. So it offers the weight and rigidity ratio, allowing the car to be lightweight while being strong. And lastly, it's best choice for race car due to the lightweight and better rigidity. So disadvantage is the tubular chassis are kind of complex because of the geometry, and it's usually not cannot be mass produced. Next, so this is advantage and disadvantage for monocoque. So the advantage is safer compared to other chassis due to the cage-like construction, and it's easy to repair and also has the super rear torsional rigidity. So disadvantage is this chassis is kind of heavy, and can it cannot be used for cars that are not easily mass produced. So these are the commonly used for material for the chassis. First, the steel, low carbon steel, aluminium, and aluminum alloys. There are different kinds of steel for each. So my problem statement is that is low fuel efficiency for the car because due to the weight. So when the heavy is low, it can cause a high amount of CO2 to the environment, which is really bad. Uh, so lastly, if the material is light, so the chassis must be able to withstand vibration, shock from any mechanical parts, and stress for stability and handling of the car, and also the uh, so my objective for this project is to design and analyze the chassis for two-seater car that can withstand the load applied on. So this is my literature review. So I found some of the research paper commonly says about the load on chassis and also the material selection. So in load on chassis, from research paper by Gold. It says that longitudinal load transfer can be lowered down by increasing the wheelbase of the car, decreasing the height of the center of gravity, and providing soft and initial acceleration. So this is a ways that we can increase the efficiency of the car. As we know, there are many loads that can uh, loads that occur on the chassis. There are lateral load, longitudinal load, asymmetrical load. We also need to find about the torsional stiffness and also the bending stiffness. So yeah. And second is about the material selection. Research paper by Chandan made an analysis about design analysis and optimization of racecar chassis for its structural performance. And the summary output says that material with high stiffness and strength can ensure the safety of the driver during extreme conditions. So by selecting a proper material, it can save the driver from uh, any condition, impact in front or side. So the chassis itself can protect the driver. So the methodology. So this is the first part of the project. So it starts by determining the product design specification. So we need to know all the parameters that we need. And second, we try to make the preliminary calculation. As I mentioned, there are many loads such as torsional, lateral load, longitudinal load. And next, we come up with a conceptual design and make a vehicle analysis, such as we know, there are impacts that can occur at the side of the chassis, front, rear. So then we'll verify by using the axis. If the chassis fails, we need to redesign back. So if it passed, we come up with a conclusion. So this is the chassis specification. So as I mentioned, we using the tubular chassis and the material type is common steel. This is the dimension. We usually take Proton Satya as our benchmark to produce a two-seated car. So the length is 3905 mm, width is 1710, height is 1400 mm. So this is the material properties for common steel. Here. And this is the product design specification that we collected from all departments, from engine, from bodywork, um, steering, and also brake. So here is the preliminary calculation for torsional stiffness. The formula of torsional stiffness is the torque divided by angular deflection. So the first one is the angular deflection formula. As you can see, the delta here is uh, the value of the deflection that standard by the FSAE rule, and LF is the length of the lateral chassis here. Stated L graph, that's the length, and from here we are able to get the angular deflection. So next, RL and RR is the load that applied on the chassis, which divided by 2 because there are two sides, and LF is the half of the value of LF. So we only calculate half of the lateral chassis here. So from this calculation, we are able to calculate the torsional stiffness, and the value is 1.1353 Newton. And here is the preliminary calculation for force for frontal impact. You know the formula of force is F equals to ma. We already know the mass of the car, and acceleration is the assumption by us, which is the 16.67 meters per second square. So the value of the force is 30 kilonewton. So this calculation will be used in the ANSYS software. So we will apply the force at the front and we assign the fix at the rear of the chassis. So we next, after the preliminary calculation, we will come up with the conceptual design. So first is the chassis design. I designed from the CATIA, and next is the packaging of car. So the value here we are able to obtain from the CATIA itself, the distance from the wheelbase and the center of gravity height. So we can obtain from the CATIA. So after conceptual design, we will make the verification using ANSYS software. So the data from the CATIA will be transferred into the ANSYS for stress analysis. But before that, we need to assign the support and force. So let's say if we making analysis for frontal impact, the field support will be at the rear and the force will be at the front. And the force, we can use the preliminary calculation force and insert it into the ANSYS program, and then we can run it. So, however, my program didn't show the stress analysis, maybe due to the design, and sometimes my program usually stop during run the program. So at the right side, I'll show the example analysis result that's supposed to come out. At the As we're making a frontal impact analysis, we will show the different result at the front. As we see that we can see the red color and green color, and from that we are able to know whether the chassis is in safe condition or not when the force is applied. So expected result. So my expected result is the design must for the von Mises stress must not exceed the ultimate strength of the material, which is 590 megapascal, and small deformation value for the design chassis. So secondly, design a chassis that give the high torsional stiffness value, which exceed the acceptance criteria for the better handling of the vehicle. So that's all for me. Thank you.